This ends now!
In this video, I'm going to be talking about vitamin B12 deficiencies and how they interact with M1 phenotypes and M2 phenotypes. So M1 phenotype, it's basically the phenotype that attacks cancer cells. The M2 phenotype protects and supports the cancer cells and tumors. So if vitamin B12 is low or deficient, homocysteine accumulates, and homocysteine is related with a lot of different and negative health consequences, such as atherosclerosis, high inflammation, cancer risk. Also, cysteine is low as a result of vitamin B12 deficiency. What that's going to do is that it also reduces glutathione, and advanced glycation end products will not be able to be reduced or cleared. What those ages are going to do is make the ECM stiff, or ECM short for extracellular matrix, and then immune cells and T cells cannot enter the ECM to attack cancer cells. Okay, so the more technical way of saying that is, okay, so glutathione is required for 4 glyoxylase systems. These detoxify MGGO. MGGO is another way of saying advanced glycation end products. Without glutathione, these MGs, they attack amidori intermediates, and then ECM proteins or extracellular matrix, such as collagen, elastin, and fibronectin, they become glycated because advanced glycation end products, therefore leading to ECM stiffening and rigidity, and then excluding immune cells to fight the cancer cells, or immune cells can't fight the cancer cells. So ECM rigidity leads to the activation of integrins, also TAZ, which is for another video, and then NF-κB. So what that's going to do is that it's going to eventually suppress the T cells so that they are exhausted, and then the chromatin ends up closing. And then once the chromatin closes, that part is very difficult to reverse. So that chromatin closing, because of NF-κB, requires a very long and grueling process and very difficult to reverse to bring back exhausted T cells. Because if the exhausted T cells aren't brought back, then the cancer metastasis is possible. And all because of a vitamin B12 deficiency, making the ECM, or extracellular matrix, rigid or stiff. Okay, this is why a vitamin B12 deficiency has to be fixed in combination with an M1 phenotype, because vitamin B12 it's a good combination or a good team combined together with an M1 phenotype. But without the vitamin B12, that leads to ECM being stiff and rigid. What that does is that the M1 phenotype becomes overactivated. So that's good to have T cells to fight cancer cells, because that's what an M1 phenotype does. But an overactivated M1 phenotype will actually overactivate T cells, and then the T cells will be attacking and damaging healthy body tissues. Now, what this ends up doing is that it could end up shifting to an M2 phenotype, which supports Tregs or Tregs. The reason why is because overactivated T cells cause the shift from M1 to M2 phenotype. And then the Tregs come in and then steal the IL-2 away from T cells, making T cells weak. So there's a double negative there. The ECM is stiff and rigid, and the immune cells are weakened by IL-2 being stolen from them by Tregs. Okay, a good process to reverse or cure a vitamin B12 deficiency. Okay, so first, starting with the lysosomal membrane, is that it cannot be peroxidized, or LMP for short, because then the iron will escape the lysosome or will not be processed by the lysosome correctly. So to fix the membrane leakage is by using magnesium. A good way to make sure that you're getting enough magnesium is to make sure that your estrogen levels are supported but not too high. That could be by reducing excessively high testosterone, because high testosterone reduces estrogen. The reason estrogen is important is to enable or to support the magnesium transporter. So what could cause high testosterone? Possibly excessive zinc, because zinc boosts testosterone. A good way to bring down zinc is with quercetin. Quercetin chelates zinc, and it also manages zinc levels. But it's a whole another rabbit hole for a different video. So with a proper estrogen levels supporting the magnesium transporter, that allows the lysosomal membrane to be repaired for iron to be processed correctly. The reason iron is important is because vitamin A is dependent on iron, because vitamin A is responsible for the parietal cells in the gut to produce intrinsic factor. The reason intrinsic factor is important is for vitamin B12 to work efficiently and to be processed. Vitamin B12 will not work without intrinsic factor. Once vitamin B12 is fixed or the deficiency is reversed, that will allow glutathione to be able to work as well. Also, homocysteine levels will go down as well, reducing cancer risk. Okay, so fixing a vitamin B12 deficiency also reduces the advanced glycation end products, because glutathione is involved in reducing the advanced glycation end products that are making the ECM rigid. So to prevent and stop the rigid ECM from overactivating T cells that are attacking the healthy bodily tissue. So if a vitamin B12 deficiency is not fixed, then it can create a self-amplifying loop with the chronic M1 signaling. This is because persistent M1 phenotype allows antigen presentation to be aggressive. So that means that the T cells are very well trained and very well armed, increasing T cell cytotoxic tone and activity, resulting in bystander tissue damage. Also, mitochondrial injury as well, which means a reduced ATP. Also furthers carbonyl stress, or basically that means that, or as I said earlier, the self-amplifying loop, that further carbonyl stress. A carbonyl is another word for advanced glycation end products, that will end up enabling or enforcing the very cause of this so that it never ends, which is the ECM being rigid, because advanced glycation end products make the ECM rigid, therefore leading back to the very cause of the ECM rigidity to occur all over again, which is the excessive M1 phenotype of making T cells too overactive and attacking healthily bodily tissues. That's also going to eventually skew to an M2 phenotype that supports tumor growth and survival. Okay, so a quick recap to fix vitamin B12 deficiencies: ensure enough estrogen to allow a magnesium transporter to fix the lysosomal membrane to keep it repaired, so that iron enables vitamin A to make the intrinsic factor that the vitamin B12 depends on, to increase glutathione, so that glutathione reduces the advanced glycation end products that are making the ECM stiff. Because if the ECM is stiff, that allows the self-amplified loop. And this self-amplified loop is the ECM rigidity causing overactive M1 phenotypes or overactive T cells to attack healthily bodily tissue, eventually skewing towards an M2 phenotype, but that supports the tumor. So that's it for the video. Like, comment, share, subscribe. Keep it locked here on this channel for future videos, and I'll see you in the next video.